Welcome! I'll explain today what a fishbone diagram, also called an Ishikawa diagram, is used for and how we apply it to SKF industrial shaft seals. A fishbone diagram is a structured root cause analysis tool. It helps us capture all plausible causes behind a problem in a cause and effect format, instead of jumping to conclusions. A key point is that it lists potential failure causes and then we work through them systematically, one cause category at a time, checking evidence and ruling out what doesn't match the facts until the most likely root cause remains. In the SKF industrial shaft seal context, the effect we investigate is typically seal leakage. The fishbone used in the seal failure analysis section highlights that leakage can have several potential causes, and only one of the major cause categories is the seal itself, meaning the leakage is often driven by the system conditions around the seal. To make the analysis complete and repeatable, we apply the standard 6M headings: man, machine, material, method, measurement, and Mother Nature environment. As we go through the diagram, we'll use these 6M lenses to review the typical seal leak cause categories, and we'll eliminate candidates step by step, based on what we observe and measure. We start at the head of the fish, which represents the problem we want to analyze: seal leak. This is the effect, not a conclusion, but the starting point for the analysis. The purpose of this diagram is to understand why the leak occurs, not to assume that the seal itself is defective. We begin on the right-hand side at the top with customer installation, because installation-related issues often explain early leakage. In this category, the diagram highlights potential failure mechanisms such as incorrect seal installation or orientation, damage during installation, for example from sharp edges, splines, or improper tools, contamination introduced during assembly. This category mainly relates to man and method in the 6M logic. At this stage, we check installation procedures, tools, handling, and visible damage to either confirm or exclude installation as the root cause. Moving left, we reach the shaft category. Here the diagram shows potential shaft-related causes including shaft geometry deviations, surface finish issues like lead, manufacturing defects like scratches or nicks. This category belongs primarily to machine. We examine the shaft counterface, wear patterns, surface condition, and movement behavior. If the shaft does not meet requirements, stable sealing is not possible, regardless of the seal type. Continuing further to the left, we arrive at the bore or housing category. Typically, potential causes shown here include bore geometry issues such as diameter or roundness, surface finish problems in the seal seat, manufacturing defects or damage to the housing. This combines machine and measurement. We verify whether the seal is properly supported and retained in the housing, and whether the bore condition could cause leakage around the outside diameter. Now we move down to the lower side of the fish, starting on the left with oil. This category includes potential causes such as oil composition, for example, viscosity, type, additives, internal contamination like particles or water. This relates to material. The lubricant directly interacts with the sealing lip, so oil contamination or incompatibility can significantly influence seal performance. Moving to the center of the diagram, we reach the operating environment. This highlights external contamination such as dust, dirt, or water, external temperature influences, and application conditions like shaft speed, pressure, shaft-to-bore misalignment, dynamic motions, fluid level, and temperature. This corresponds to Mother Nature environment in the 6M approach. These effects often explain why the same seal performs differently in different applications. Finally, just before the fish head, we reach the seal category. This includes the potential causes such as seal geometry and design, seal material, manufacturing defects, This relates to material and machine. An important takeaway from the diagram becomes clear at this point. The seal is one of several potential contributing factors. In many cases, leakage is influenced by the system conditions surrounding the seal rather than by the seal itself. Starting from the problem and moving through each category in sequence, this fishbone diagram helps us identify all potential failure causes. We then verify each category with evidence and exclude them step by step. This structured approach ensures the most likely root cause is identified and that corrective actions are defined to prevent recurrence.